APIs are a common way to access data in different source systems like CRMs, apps, open data and many other systems. API security could include different access methods. One of them is adding a signature in your API request in order to verify the user's authenticity. In this demo we are going to use the Binance API again, where some endpoints are secured, not only with the API key, but also require a signature. In particular, let's use the fiat endpoints, which require HMAC signing. Signed endpoints require a signature parameter. You need to use your API secret key and all other parameters to create your signature. Apart from that, you need to provide a timestamp in milliseconds when the request is created and sent. An additional parameter could be used to determine how long a request is valid. This can be useful if you need to pre-process something between your signature calculation and send the request. Now let's head to our Synapse workspace and create a new notebook. Change its name if you want. First, we are going to import some libraries to work with HMAC, calculate hash values, time calculations and perform requests. Let's run the notebook in advance to save some time. We are going to define a recv window value of 3 seconds. Get the current time and convert it to milliseconds. Let's print something just to check our progress. Now let's read the API secret from a key vault. We need the name of the key vault and the name of the secret. We can concatenate all request parameters in a variable. I include the recv window. Also the timestamp, which is mandatory. The transaction type. And the beginning time to scope the request to transactions from the beginning of 2022. We must encode the request before hashing it. We can print the variables to check our progress. Now we are ready to define our signature. Secret is a bad name, sorry. Let's create a new HMAC object and encode the API secret too. SHA-256 is required. We need the alphanumeric message, which is the digest. Let's define the base URL in a variable. And for the resource, let's use the fiat payments instead. Transaction type 0 means buy. All other parameters stay the same. Now we can define the request URI. Loops, we have a typo. Now we can see how the request URL looks like. To continue, we need the headers, which must include the API key in a header parameter called xmbx API key. Now is time to create the request. We can verify the status code and do some simple error handling. As you can see, we got at least a couple of orders. We can create a data frame out of the response. For that, convert the response to JSON and read the data element, which is an array of buy orders. Then get the column names in a list. The rows also as a list of rows. Finally, we are ready to create the data frame. We can display it to verify our results. We can see two transactions, where I bought USDT and Bitcoins using Euro and my credit card. It's time to persist the incoming data in a Delta table. For that, you need the URL of the storage location, specifically the ABFSS path. Let's call the table fiat_buy. Write the data frame with Delta format. Let's check that it was created. Finally, let's create a table in the Lake databases. We can use one existing database. The path is the same we used above. Verify the newly created table is working. Note the nice delta icon in the table. Just use a simple query. And this is the end of this exercise. I hope you enjoyed it.